Hi, today we're going to talk about how to calculate the arc length and the sector area in degrees, both in degrees and in radians. I use this chapter a lot to explain to students what radians are and how to use radians because normally students are used to degrees, and suddenly when radians are introduced, they don't understand why we have to use radians, and they come in very handy in this chapter. Okay, so what is our aim? We want to calculate the arc length. So we have a circle here, more or less, and we want to we've got here an angle, and we want to calculate the circumference, the section of the circumference which that angle gives us. So this is the arc length, the one I'm going to draw in red. Okay, and the area we would want to calculate would be the one I'm drawing in green. Okay, so that's the sector area. This would be the arc length, and this would be our sector area. Okay, so I'm going to give you both formulas, both in degrees, which I know you're more used to, and in radians, and I'll explain why in radians it's easier. So we're going to make a quick table here. And first of all, what is the arc length? What is the arc length in degrees? Okay, so it's very easy. The formula is 2 pi r. We're going to call the angle in degrees alpha divided by 360. Okay, and our sector area will be pi r squared, our angle in degrees, divided by 360 degrees. So those are two formulas you can learn. I don't recommend to learn those, and we'll see why. But those are two formulas we can learn. Okay. So now, let's talk about the radians. Let's remember how to convert from radians into degrees, or more precisely, from degrees into radians. The way to do it is to do a ratio, where if we have our angle in radians, we want to know our angle in radians, we could do a ratio, radians divided by degrees is equal to, and any angle that we know, for example, 2 pi in radians equals to 360 degrees. Okay, so that's if we now put radians as our subject of the equation. We have 2 pi divided by 360 times our angle in degrees. I'm going to call our angle in radians beta, and our angle in degrees, I'm going to call it, as I did in the formula, alpha. Okay, so our angle in radians is going to be our angle in degrees times multiplied by 2 pi and divided by 360. Okay, so I was just reminding you how to convert from one to the other. So, but if you see, we have this part of the equation, that's our angle in radians, and this would be our angle in radians divided by 2. Okay, so if you follow me right now, in radians, our arc length would be, this was our angle, so we have radius multiplied by our angle, a much easier equation. Okay, and if we do the same thing here, we said we had, that would be our angle in radians divided by 2, so I'll put our angle in radians divided by 2 multiplied by r squared. So our formulas in radians are much easier for the arc length and the sector area than they are in degrees. Why? Because precisely our conversion from degrees to radians was to multiply by 2 pi and divided by 360, which appeared on both equations. Okay, you can observe that the arc length would be the radius times multiplied by the angle in radians, and the sector area is angle multiplied by r squared divided by 2, again in radians. So very easy equations. I recommend you to learn these ones and learn how to convert from radians to degrees, and then you get the other ones if you need them. Okay, so let's look at two exercises. We're going to find on our first exercise the arc length, and the other one um, the sector area. So imagine we have 120 degrees here and 2 centimeters, okay? And we want to find this arc length. And I'm going to calculate it both in degrees and both using degrees and radians, just so that you see that it makes no difference, but it's easier in radians, okay? So we want to know, we want to calculate the arc length, and we saw that in degrees that was 2 pi divided by 360 multiplied by r and the angle. Okay, so that would be 2 pi. R is 2, the angle is 120, and 360. Okay, so if you calculate that, that gives you 4 pi divided by 3, which is more or less 4.19 centimeters, which would be the arc length. Okay, so now let's calculate it in radians. In order to calculate it in radians, I would need to know how much is 120 degrees in radians. So we needed to multiply 2 pi divided by 360 times the 120. Remember the formula we used here. Okay, so that's, if you calculate that, that gives you 2 pi divided by 3. Okay, yes, because 120 divided by 360 is 3, and that's equal to 2 pi divided by 3. So the arc length in radians was very easy because it was just multiplying the radius times the angle. So that's 2 times 2 pi divided by 3, 4 pi divided by 3, which is more or less 4.19. The same answer, obviously, but much easier. And the formula, again, is much easier to remember. Okay? Let's do another exercise where we're asked for the sector. So now we have, let's say, 30 degrees and 3 centimeters, okay? And we're asked for this sector area. So we need to know the sector area. Again, if we remember the formula in degrees, that was 2 pi, pi, because it was the angle divided by 2, okay? So now it's pi divided by 360 multiplied by r squared and the angle. Yeah. So that's pi times 9, 30, and divided by 360. And if you do that, that gives you 3 pi divided by 4, which is more or less 2.36 centimeters square, as we're given the length in centimeters. Okay, so that would be the arc length. Again, not very complicated, but the formula is a bit complicated to remember. If we do it in radians, again, we need to first calculate 30 degrees in radians. Okay, so that would be pi 6. Okay, so the sector area, the formula is very easy. R squared divided by 2 and the angle. So it's 9 divided by 2 and multiplied by pi 6. And that is, as you can see, that gives you 3 by 4, which is again the same 2.36 centimeters squared. Again, same answer, but the formulas are way easier in radians than they are in degrees. Okay, so I hope this helps you. Again, you can calculate both the arc length and the sector area, both in degrees or in radians. In radians, the formulas are much easier. I recommend you to remember the formulas in radians and know how to convert from radians into degrees.